All right, here we go. Here's a logarithm. You either do it or you don't. There is no I don't get it. You just need to know what a logarithm does after what I described to you right here. So here's an exponent. Get these positions really labeled out in your mind. You have some base raised to some power equals some answer. I just like calling that the answer to an exponential scenario. So base raised to an exponent equals an answer. This is all a logarithm is. And I have this written below this, but I just want you to focus on these two things. All a logarithm is some mysterious, magical algorithm that when I insert the word log in front of this, these positions go, they change, they flip around. So I throw the word log in here, the base becomes this lower subscript. The answer goes in this position as a regular size thing, and then here's the glory and power of a logarithm. Equals, it gets the exponent isolated all by itself. And that's the point of a logarithm. The point of a logarithm is to get the exponent out and isolate it outside. Get it out of that exponential scenario so I can solve more complicated questions. Like in your homework, which I didn't collect. Did I collect the last hour? I don't even think I did because I'm collecting piles of papers and I'm starting to stop. I'm stopping my stamping for a minute. So maybe just hold on to your stuff. How many papers do you have right now from this chapter? You already have 2? So we'll do a 3 turn in, maybe, and then I'll stamp. All right, I don't know. I just don't want more papers in my desk. It gives you an extra day or so. What was I saying? I don't know what I was saying. But anyway, that's what a logarithm is. You just got to know it. So I put some things off to the side. Of course. Oh, boy. This program got little. You left me alone for a second. I'm mad at you now. Okay, put those down real quick. Then I actually realized I got to do something. Copy and then paste. I need this for 7th hour. Okay, and then the alternative logarithmic form. Okay, then I'm actually going to add a third. Here we go. Oh, no. What do I want to do here? Nah, never mind. I was trying to think of something else, and I just lost it for a second. Okay. Yeah, all right. So anyway, 6 squared equals 36. Okay, here's the problem with logarithms. It's not logarithms, it's exponent rules. So first of all, knowing the negative exponent rule. I have an idea. I know what I'm going to do. All right, and then 2 to the negative 4th is 1 over 2 to the 4th, which is 1 over 16. So you're going to be on call to know the negative exponent rule when you're evaluating logarithms. Now I got it. Add one more. Because really what I felt last hour is I was lacking in another thing about exponents you should know. 8 to the 2/3. Now, this is back in August when you guys all got the first 2 days of lessons, and you flipped out and ran out of the room and said this class is impossible. All right, it was the exponent rules and radicals and square rooting and simplifying radicals, and we did it in 2 days thinking you were okay with it, and nobody was. All right, so we knew we had a problem with what happened last year and the year before. But what is 8 to the 2/3? 3 means cube root. Everybody, what's the cube root of 8? In 3, 2, 1, go. 2. And then the 2 is squared. So what's 2 squared? 4. So knowing that is also a problem if you don't, because we are going to have logarithms that expect you to know these exponential rules for sure. So now what I have written off to the side is the corresponding logarithms. These are equivalent expressions. One's in log form, one is in exponential form. And that's what I want you to understand. As Kathleen, who got her number picked, she's going to have to answer a logarithm question. If you understand this, you'll be able to answer the question. So here we go. Log base 6. 6 is the base. 6 is the power, the number being raised to a power. 36 is the answer, equals 2 the exponent. So when you see a logarithm, you're supposed to be able to say, okay, this means 6 squared equals 36. Got it. And that's true. A little bit tougher, 2 to the negative 4th, hold on. That's 1 over 2 to the 4th, which is 1 over 16. Just changes the positions. Then this last one, log base 8 of 4. Holy cow. You're going to have to figure out that that's 2/3 through knowing your exponent rules and all that other stuff. That's why I like throwing that last one to remind you of what we taught you in August. And I think it was a taught, not review, because a lot of you didn't know this, and it was pretty rough. Okay, so back to this. I actually literally said that. Log is a mysterious algorithm that rearranges the positions of an exponential equation so that the exponent is isolated. Alrighty then. You shook your head no? Oh, you went like this, I thought. Oh, okay. Oof. I think my diatribe earlier made me a little hot there under the collar. See, White Sox to White Sox. Isn't that nice? How many people wore their sports shirt? Anyone? Nice. Sports. A lot of Bulls. The Bulls are coming out of the woodwork now because the Bulls are getting better. All right? It's pretty cool. Aren't the Bulls, don't they have like a lot of wins already? How many people follow the Bulls? How many? What are they? Did they lose yet? They're 4-0. Oh, I do like. I'm a fair weather Bulls fan, so I'll have to start watching them again. The last fun days were like Kirk Heinrich and were you guys even born when Kirk Heinrich was playing? And what was the other guy? Flash Gordon, Tim Gordon. He would come off the bench and score like 30 and a quarter sometimes. Those are fun days. And then of course Derrick Rose. Those are good days too. All right, so here we go, Kathleen. And I wrote this out for you though too for the first couple. Oh, who's going to get B? That's going to be a tough one. But log base 2 of 8, this is what this is asking you, Kathleen. 2, I have this in words over here, to what power equals 8? What's the answer, Kathleen? 3 is correct. And that's it. It's just the power. It's just that number. And you're done and you move on. Oh no, who gets the next one? Now this is what I mean about it being all about exponent rules. We got a lot of absences here. The other thing is absences. And then people coming in, where's the worksheet? Oh, and it's just like a kick in the groin when someone asks me that when I put everything on the calendar. It really is. But anyway, just complaining again as I see a lot of absences out in here. Hey, Ashka, you're 17. Oh no, you got this one. You know the answer? Last hour didn't either. I did put this here. These are 2 invisible things. These are 2 invisible things. That's a square root, so there's a 2 there. This is 3 to the 1st power. So really what we're asking is, how do I rewrite the square root of 3 into 3 to what power? Not 2 over 1, flip it. It's 1 over 2. So this is equal to 3 to the 1/2 power. And that's what it is. It's not logarithms that screw up people. It's you don't know your exponent rules. And your exponent, like in this case, this is a different meaning. So what's your answer? Is it 3 to the 1/2 or is it just 1/2? It's just the power. So it's 1/2. And then now I have to erase that because it's in the way. The next one, I'm going to be honest, you should get this one, but we'll see what happens. Jake, you got picked. Student number 5. What's C? Oh, Jake's got to pay attention now. He doesn't usually take notes. Sorry, Jake. It's the truth, though. Anytime your number gets picked, it's always like a reboot. Even though you know what you're doing, you got to collect yourself. So 5 to what power equals 1 over 25? Okay, we'll go back to the notes because we're not going to let you go on this. It really pertains to this. Take a look at that one again that you didn't take the notes on. Sorry, Jake, I got to go there because you got to be focused during the note sessions. So now what is the power? Oh, boy. Okay, so what is 25? 5 to what power? 5 to the what power is 25? Okay, there we go. And then how do I make this 1/5 5? What do I employ? What rule for exponents? And it goes back to this. Look at 2 to the negative fourth. What did 2 to the negative fourth become? Say that number. 1 over 2 to the fourth. Okay, so then what is 1 over 5 squared? 5 to the what? It's using the reverse. Just say negative. Okay, so now answer this question. What is the exponent on 5 that becomes 1 over 25? It's negative 2. Okay? So you got to focus here. All right? Just like this. 2 to what power equals 8? 2 to the third. 5 to what power equals negative 2? 5 to the negative second. I should put bases of 5 on this one. So it's just that power. All right, 14. Who's that? Matt, isn't that you? All right, think about this one for a second. 4 to what power equals 1? Oh, no, because 1/4 times 4, that's not what's happening. I need to know what power that equals. Oh, darn it, I just noticed something is written here that I didn't want.
0.
Anything to the, say it again. Matt, let's say this together. Anything, Matt, say that.
Anything
To the 0 power equals 1. There you go. You finished it off. So it's 0. That works. All right, next. And then the next person's 19, which is terrified of going. 22, 21, 20, Ivo. There's an absence. 19, Sam I am. Log base 7 of 7. 7 to what power equals 7? 1. Right? And then that's going to lead to some rules that we have here. All right? So follow along. Logarithms are not hard. You just this sentence right here. A little stumbled why we have some issues here with getting these answers. All right, now go to your calculator. Go ahead and get it out. Play along with me here. Or not, if you don't get focused in the notes on a daily basis. Oh, teaching in America. Mr. Samuels is going crazy right now. He is about to go insane. Okay, so now getting your calculator out. Oh, good, you got time because it takes like a minute for my calculator to open. We'll wait for it, wait for it, wait for it. Alrighty then. Okay, and I got to clear because that's what some stuff I did from the last hour. And then I'll hold because you guys always trust that calculator. This was Matt's question. Why is log? Oh, by the way, I'm going too fast. Look at your calculator again. I should open that up because I was jumping ahead of myself. And then where are the log buttons that you have? And they're down this row here, right there. You have log. So wait a minute. You just told me that we have bases and stuff. Oh boy, I'm in the way here. Okay, so I'll move myself over there. We have bases, but this one doesn't have a base. Well, you do. It's written in red. Sorry, I can't erase it. I wrote this back in the day. The invisible thing, there's a lot of invisible things in math. Ashka, wasn't it you that had that square root of 3 question and you had to get 3 to the 1/2? The square root doesn't have a 2 as a base, but it's there. 3 to the first power. You don't ever see a first power. There's 2 invisible things. Here's the third one. Whenever you see a log with no base, by default, that is base 10. So, but back to Matt's question. 10 to what power equals 1? What's the answer, Matt? 0. 10 to what power equals 10? I forgot who had that one. Sam. 1, right? These are all make sense. And then this one, log base 10 of 10 to whatever power is the power. And I have this written over here. Log 10 raised to the 21st. Let's go to the calculator and prove that the calculator button is base 10. Log 10. 10 to what power equals 10, everybody? The answer is 1. I'm in the way, but you can barely see that 1 there. 10 to what power equals 1? The answer is 0. See, now this is that doesn't prove that that's base 10. But I'll do that third rule. Watch this with the glory and power of calculator. And by the way, if you use your calculator in today's homework, good luck on failing on your quiz. Bam! That's a shot. That's actually saying don't touch your calculator. I'm only doing this to prove that the log button on your calculator is base 10. Boom shakalaka, there's that third rule. Log base 10 of 10 to whatever power, the answer is whatever that power is. That's what that third rule says. Okay, so we can use the calculator as a little aid in understanding. You should not touch your calculator once. Well, that's a lie. There is one little section that says use your calculator. One little section, and it is in our notes. And then this last rule, I'm going to prove this rule. And then actually when we get to the homework, I'm going to prove this rule again by, hey, I don't remember this rule. I'll give you an escape, how you can get out of this. And actually, this is really, oh boy, I love this pro. It's not going to work until I go out and in. Got all fussy on me. The book is really bad with their notation. This is really what this, it's 10 really raised to the log of x equals x. That's what that says. Log base 10 raised to the log base 10 of x, that will equal x. Whatever that is right there. Now I'm going to prove that. I actually always had a problem with this rule. I think this was the first cat book I ever taught out of that I saw this new weird rule. So I questioned it. I created a new variable. I said, hold on a minute. I don't get that. I'm going to make up something. I don't think that's right. How did they come up with that? How could I prove this? It actually has to do with what I have here. And this is the main idea from a logarithm to an exponent and an exponent to a logarithm. So what I'm going to do is change this to a logarithm. I'm going to convert this, but there's log already in there. No. This is exponential form. You have a base raised to an exponent, and here's an answer for that. And this exponent just happens to be a logarithm. What I'm going to do is change it to a logarithm. And then this is just understanding what happens when I throw the word log there. First of all, everybody, and it should be everyone that gets this, what goes in that position? Is it this, or this? 3, 2, 1, go. 10. Good. Then what goes in this position right here, as big as log? There's only two things left. It's exponent or answer. 3, 2, 1, go. Answer. That's the question mark. Okay. Now I got that in that position. So what's left? Equals the exponent. I thought maybe I was getting low on power. My screen just dimmed. And the exponent is this. Just by being a human and looking at this in simple matching, what does question mark have to equal? 3, 2, 1, go. X. I mean, that's what it means about being a human. Question mark is in the exact same position as X is. So therefore, there is understanding now. Oh, okay. So then that position actually should equal X because of everything I just did right there. That little progression of thoughts. Okay, do not write this down. It's the same rules, but it's just saying that there's another log button on your calculator. All right, now go to this calculator button. And actually, I should introduce who E is, but it is right here. It's below log. And actually, what this is, you know what? I'm just getting rid of it. No one wants to see my ugly face anyway. All right. It's actually log base C. So you should write these down, though, underneath and separate from the log base 10 thing. This is mathematical laziness. Mathematicians are so lazy that they changed log base E, which is 4 letters, down to 2 letters. I'm being serious. You need to know that ln actually means log base E. Then you have to ask yourself, who the heck is E? Well, E is almost as important as the number pi. By the way, what does pi deal with? What kind of object? Anything dealing circular, pi gets involved. And then it's important in those kind of things. E, and I'll tell you why they call it the natural log. E actually comes from an expression, and I'm not going to bore you with what that expression is. I kind of forgot what it is. I think I kind of know what it is, but I have to double check. Becomes 2.718 when you do this particular expression. And actually, why it's called the natural log, it's important in growth and decay situations in the real world. It's actually true. how E is developed, it actually relates to growth of populations, both bacterial and human, um, growth of money, and decay of other things, decay and blah, 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 blah. So it has a lot of applications to the real world. That's why it's called the natural log, natural processes. True story, all right? That's why we call it that. But anyway, this is the same set of rules, just with a different base on the logarithm. And now I'm going to go ahead and exercise these rules. By the way, Matt, e to what power equals 1? 0. Anything to the 0 power equals 1. And then look at this next one. Boom. ln, and then I'll show you where you can find e. There's a couple spots for it, but there it is. It's the second division thing. So just like I did log 10 and I got 1, that's because this is base 10. ln of e, that's because it's log base e of e equals 1. And then that next one, ln of, and then look at where e to a power is. It's second. Oh, shoot, I just did that. Okay, oh, shoot, I didn't want all those to go away. I meant ln, and then second ln is e raised to a power. 56. I just made up something. What's the answer to this going to be? 56. Okay, because it's e to what power equals e to the 56th. The 56th power is what the answer is. Right? And that's what that third rule says. And then I'm not going to bore you with the fourth rule. It's the same proof. I could do what I did with the last one. Okay? And that's why I wrote this. ln of e to the, I just love these notes. Got to go out and go in because you went to the calculator. I'm mad at you. You left my program. Boom. All right. Now, here we go. Kathleen, you already went. Actually, we got to have a whole new set of people. Now, here we go. This is where the stuff's going to hit the fan, so to speak. Do we truly understand? This is your job. Did I do Stu 467? Yeah, Sam, you went. 2021. Okay, so what's our first logarithm? Evaluate without a calculator. What do you think that answer is? I'll give you a hint. Matt is the key on this one. 0. I hope you just didn't copy Matt's answer from a couple questions ago. Hopefully you understand 6 to the 0 power does equal 1, so the answer is 0. Okay, who's next? Ooh, this one makes me nervous. This was a little rough in 4th hour. Student number 11. Nice. That's McKenna, isn't it? Oh, McKenna, I'm sorry. You got a tough one. By the way, see how this is 6 and this is 36? Make 36 6. 6 to what power equals 36? Okay, so here's how we're going to break this down. And then it's a little bit of what happened with Ashka. All right? This is now 1 over the 5th root of, log base 6 of 1 over the 5th root of 6 squared. Now do what Ashka did. This is, look at my 6's and G's. Don't they look the same? Sorry about that. I remember an honors algebra 2 student, like halfway through the log chapter, whispered to a student, what's LO6 mean? We were halfway through the log unit. He didn't know the G was not a 6, and remember that kid. Okay, here's what I was asking you. Wonder if they watched my videos. Hey, that was me. I didn't know watching these. McKenna, 6 to what power on the bottom then? Nope. What I'm dealing with is this, and this is what Ashka had to do. How does this turn into a power? I'll give you a hint, it's a fraction. 2 over 5. Okay, now I'm going to tell you right now the answer is not 205. 2 over 5, I mean, when we tell me what the final answer is. So the last thing you have to do is figure out how does this become 6 to a power, and then that's the exponent. What's the flipping rule? What happens to the exponent when you flip? Oh, you switched that. No, this is what we're asking, the last part. And this is where we get troubles with logarithms. It's not the logarithms, it's the power rules. Now what is that power? And then therefore that'll be the answer in this circle. And it has to do with what we showed, and this is why we do beginning things. Right there. This is the reverse of it. But if you had a positive exponent in the bottom, it comes up to the numerator and becomes what? What does the power become? Starts with an N. There we go. So that's why we build on these things. That's why we need to do that. So what's your final answer for this then? What's the both circles? That's what happens. You don't flip ever a fractional exponent. What you do is you flip the whole number with the exponent, and the exponent becomes negative. Or if you have a negative exponent on the top, you flip it, and the exponent becomes positive. One or the other. You got to get that figured out. All right, student number 3, Kathleen. Hey, Kathleen, I got to know how 10 powers of 10 work on this one. And by the way, Kathleen, I did a disservice. This should be invisible, and then you as a student have to know, oh, that's base 10. So 10 to the what power equals 10,000. What's the power? What's that? Not 100. Okay, I think you were trying to take 10 times 100 equals 10,000. Not what happens. Okay, so what is 100 though? That's 10 what? 10 to the what power? 100 equals 10 what? Trying to build up here. 100 equals 10 what? What's the power? 10 to what power equals 100 is all I'm asking. Second power. So 1,000 is 10 to the what, everybody? Third. And then 10,000 is 10 to the what power? Fourth. Okay? So these are the things where we got to be numerate. This is why whenever we see like log base 10 and we have like 1 with a bunch of zeros, it's really about counting the zeros. That's really all it is. Right? See that? Okay, so we should be able to do that without a calculator. All right. Oh, no. Here we go. We got through this in 4th hour. Hopefully we do here. Nice, Adam. By the way, just in time for Halloween. Boo. What is the ghost right there? What's the base? So it is log base 10. And then when you get good with this, you'll get the answer right away. And I bet you some of you already have the answer. Okay, so what did I say 1,000 is, Adam? 10 to what power? Okay, so it's 10 to the third. And then you got to do, and we're going to pick on Ashka. We're not picking on her. We're saying what she had to know on that very beginning question so we can build on things. What's the final answer? Do you already know? Oh, you messed up. No, it's on the bottom. So what kind of 3 over 2? Okay, so here's what you said. Here you go. I think you were still saying that this is 10 to the 3 over 2, but it's still on the bottom. And then you had to do what 2 students had to do ago, McKenna. You have to understand that we have a negative exponent here. So it's negative 3/2, and I got to do that. To get that flipped, I need to make the exponent negative. And then what we're getting is we're getting this down to this rule. We're getting this down to this rule right here. That's what we're trying to do. Log base 10 of 10 to what power? We're trying to figure out what's the power on 10 so that I can answer the question. Okay, so it's all about these exponent rules. It's all about what we're supposed to know walking in here. This is often a rough thing, though. 15, 4, 8, 12, 16, 15. Nice. Evan, what do you think the answer to this one is? It is -4, and I'll explain it. It's because ln is what, everybody? Log base who? Don't say 10, it's log base who? E. So log base e to whatever power, it's the power. Right? And it goes back to that rule I just showed you with the log base 10 thing. Okay, leave that up there. Oh no. And I'll tell you, last hour's kid was paying attention and focusing, was able to just tell me the answer at the end. Let's see if we can get that with the students here. Clear. Student number 8. Nice. I put you on the spot, Dana. Do you know the answer? This would be awesome. Putting all the things together that you've seen everyone have to do. 7. I'm still listening. 7 what? -7 over. Oh, what's the invisible index that's never written? 2. There you go. So that's putting it all together. This is where we should be able to get. We should be able to get that this is log base e, and there's e as a base. So therefore, I just had to figure out the proper exponent where this is log base e of e to what power? And then be able to do all that math in your head. Okay, 7 over 2, but it's down on the bottom, so it has to be a negative exponent. That's how this works, and that's where we need to get. So therefore, that's the answer. Okay, where are we at? People are putting their stuff away. What's going on here? That we have till 55, 18, 16, 17. Nathan, nice. Nathan, I told you when we get to this position, we're going to go ahead and break this down. But do you know what the answer is? Did you take your notes and remember what this answer should be?
20?
Oh, yeah, for number 20, yes. We'll say no, and we'll go ahead and derive this. This is the one where I put question mark as a variable. Like, wait, what is this answer? And I could do that. I could do that. A variable is just any symbol that I want that represents a number. What we're going to do is change this to a logarithm. And this was the save out of this. What's the base of that logarithm? What's the next position? What goes here?
8.
Oh, it's base, exponent, answer. So what goes in there in the next position? Answer or exponent?
Yeah.
Oh, it's answer. Okay, so you got to get your logarithm down and get it memorized what positions go in what. Otherwise, this is going to be a rough chapter. I will tell you this. Anyone that does not figure out where the positions are for a logarithm, you will get the worst grade of the year on your test. There's no doubt about it. The next quiz is based off of you knowing the positions of a logarithm. So we better do something to get to where these positions are. Otherwise, this is going to be rough. What's the next thing? What do I put over here? It's not 8. It's log base 5 of 8. That represents the whole exponent, right? So all of that. Now, be a human being. What does question mark have to equal just by matching? 8. So the answer up here is 8. All right? Okay. All right, so that one is a weird one. That one, like I say, I don't remember. I think in other books I didn't have those that rule here, but it is a nice one. Ashka, boom! You didn't get picked again. What's that base right there, even though it's invisible? 10. So hopefully you get the answer. What's the answer to this one? It is just 14. Now we can just remember that. Now, I know this is an obscure rule. Why I did this with Nate here is because when you get rolling and stuff, I don't remember this, but I remember Mr. Samuels changing this to a logarithm, and it saves me. But if you can remember it, it's actually pretty fast. The next student, 1. Nice, Mitchell. What's that? E raised to the ln. By the way, what's ln? Log base what? E. So what is the answer to this one? She just got 14, so it's just 1/5. Okay, now we can get rolling and just answer it if we know the rule. Your homework's 1 through 35 out. I'm at 24 already. I know it's taken a long time, but it's a long time to set up the ideas here. Okay, this is the time where you use your calculator. If you use your calculator any other time, you're causing your own failure. All right, so feel free to punch your buttons here, but go ahead and press number 28 right now. And then press number 32 right now. I'll give you a second to do so. What did you get for 28 and 32? What did it say? What's the answer? What does it say on the calculator? Error. Here's why. 10 to what power equals negative 5.14? That's what this is asking. It really is. Can you raise 10 to a power and get a negative output? No, you can't. So this is why this is undies. And then this is asking e to what power equals a negative 3.3. And this is big stuff when we turn to graphing tomorrow. I'm actually going to have you input, say it. I'm going to have you input 3 points. And there's 3 key points you're going to input, and it's not these. I'll tell you what they are, and then it'll really make graphing. It should make it easy. I don't know why it isn't, but that's undefined. And then these work. These are like you get a number, and you can just get that number. Remember that number represents an exponent. By the way, don't touch your calculator on this. What do you think log of 0 is? Or log base 10 of 0? 3, 2, 1, go. 1, no, 10 to the first is 10. 0, is 10 to the 0 0? No, 10 to the 0 is what? Is this possible? This is going to be a key point, though. This is going to be our big input tomorrow. Even though that input creates an undefined output, this is the key to understanding something about graphing logarithms. This is the very, very start of a not possible answer. And then, of course, you can't have negatives. That's going to be a key component for our graphing. All right. Last two students. Boom. I'll tell you, student number 9 again, Adam. The last thing that we're going to do is solve. And I will tell you this, when we get into 3-4 and 3-5, that's the big solving section. I love those sections. This is why it's like, it really comes close to almost my favorite thing. I do love trig a little bit more, but I love this chapter, especially with exponential growth and how it can help you as a human being beyond just this math class. I'm going to teach you how you all can be a millionaire if you're just consistent with your investing and you commit to it early. All right, the power of exponential growth, and we're going to actually see that. But really, when we solve, it's one of two things. If I have a log, give a try changing it to an exponent. If I have an exponent, give a chance of changing it to a log. Going back and forth actually solves pretty easily. So Adam, first of all, you have this question again. What's the boo? 10. So this is log base 10. Knowing that is half the battle. And then Adam, change this to a logarithm. Change this to an exponent. I told you, you're doomed if you can't do that. Your test is going to be an absolute disaster. So we need to get this memorized. So change that to an exponent. 10 to the fourth, who is that equal? Do you see how that solves it? Just by changing this to an exponent, this made this x equals. And now I have x isolated. So that's the beauty and power of that one, which would be 1 with 4 zeros. So back to that, Kathleen, just know powers of 10. These how these work, so you can do those questions, right? You don't need a calculator. You just need to, know how powers of 10 work. And then this one, even though it's a weird answer, who adds Adam? How many times do you go? 4 or 3? 5? I don't know. 6? Nope, that's that. It goes 5. Let's end with Jake. Jake, what's ln? Log base what? Okay, so it's log base e. You're not going to be able, this is no calculator, so you're just going to have to write this in terms of e. So go ahead and change that to an exponent. Literally have to do almost the same exact thing that the last student did. Okay, good. You did your negative exponent rule too. So you try to get me the final answer all nice and clean. So this would be a possible answer, but he's right. Probably on a multiple choice scenario, I'd change it to this for like if it was multiple choice. So I like it. Okay, so e base raised to a power equals answer. That's the mystery of logarithms. Either get the positions or you don't. I even color code them. E base -7 exponent x answer. That's all a logarithm is. And all you have to do is memorize those positions, right? And then you're good to go. And then this will be a really easy test. If you don't memorize those positions, fumble, then you're doomed.